At some point, someone on your team or maybe a vendor will say this to you. We want our AI to understand our company's knowledge, so we're building a knowledge graph, and for that, we need a graph database. It sounds completely logical. Graph, graph, the words even match, and that's exactly why this decision deserves a few minutes before it becomes a line in next year's budget. Because a knowledge graph and a graph database are two very different things. One is an idea about how to organize what your company knows. The other is a specific technology with real strengths, real costs, and a much narrower sweet spot than the name suggests. So the story here is not graph databases are bad. The story is don't let the matching names make the architecture decision for you. Before we separate the two, we need one word of vocabulary because the word graph is doing a lot of work here. In mathematics, a graph is simply dots and lines, things and the connections between them. A metro map is a graph, stations connected by tracks. A social network is a graph, people connected by nodes. Your org chart is a graph, roles connected by reports to. Under the pictures, all three are the same skeleton, and once you see that, you realize graphs are everywhere. Things and their connections describes almost any part of a business. So keep this in mind. Calling something a graph only says the knowledge is connected. It says nothing yet about which technology should store it. A knowledge graph applies that same idea to what your company knows. You name the things that matter: products, customers, machines, contracts, and you make the connections between them explicit. This product belongs to this family. This supplier delivers this material. This rule applies to this market. That's the whole idea, and it's a genuinely good one. But it's a concept, just like the org chart. An org chart says who reports to whom. It says nothing about whether you keep it in PowerPoint, in Excel, or on a whiteboard. Same here, the knowledge graph is the picture of your entity's relationships and meaning. Where you store that picture and which engine answers questions about it is a separate decision, and this is exactly where teams jump too fast. So, when you turn the concept into a working system, where does the knowledge actually live? Usually, some of it lives in a database. There isn't one kind of database, and for this decision, three families matter most. First, relational databases, the classic SQL tables almost every company already runs. Great for structured data, reports, and transactions. Second, the NoSQL family. Key value stores for fast lookups at huge scale, document stores for flexible records, wide column stores for massive simple tables. And third, graph databases built around nodes and edges, three families. And your knowledge graph, the concept, can be implemented with any of them or with a combination of them. The word graph in the concept does not choose the box on the right. You choose based on the questions you actually need to answer. Of those three families, the graph database is the one everyone is pointing at because the name feels like it fits. So let's look at it properly. A graph database is one specific storage technology, and it is genuinely excellent at one thing: following chains of connections when you don't know in advance how long the chain is. For example, show me everything that depends on this component, no matter how many levels deep. Why is a graph database so good at that? Because of how it stores the data. A relational database can answer connection questions too, but the links aren't stored as links. They live as matching key values in the cells. So following a connection means matching those values across tables at query time. One join per hop, usually with the help of an index. Every extra level means another lookup. And deep, open-ended chains can get awkward and expensive unless the whole model was designed for them. A graph database stores every record with direct links to its neighbors, like saved addresses. So following a chain is not really searching anymore, it's walking link to link as deep as the data goes. The difference shows up in numbers. In one well-known benchmark from the graph database literature, on a network of 1 million people, a friends of friends question, 4 levels deep took the relational setup around 25 minutes. The graph database answered in about 1 second. Now, to be fair, it was made by the vendor side, and it was built around exactly this workload. It is not a universal database comparison, but that's the honest lesson inside it. Even the vendor's own showcase is about one thing: deep chains, not everywhere. So, when is a graph database the honest right answer? When your core questions are chain questions. Imagine a food producer with a contaminated raw material lot. Which batches used it? Which products contain those batches? Which shipments? Which shelves? However many steps that takes. That's batch genealogy, and it's a textbook fit. Fraud detection is another one. Accounts can look unrelated until you follow shared phones, addresses, and devices around a ring. Or take impact analysis in your own IT landscape. If we change the system, what breaks downstream? If questions like these are your daily bread, put the technology on your shortlist with confidence. The point is not never, it's know why. But fairness cuts both ways. There are jobs where a graph database is clearly the weaker choice. Take reporting and analytics. Average downtime per line last quarter, sales per region month by month. Those questions don't follow chains, they sweep across millions of rows and add them up. Relational engines and the BI tools on top of them have been optimized for exactly that for decades. Graph databases have not. In one independent, peer-reviewed study, a relational database ran an aggregation query about 30 times faster than the graph database. Or take high-volume records, orders, invoices, sensor readings, millions of entries with the same shape, and no deep chains between them. That's home turf for relational tables, and at very large scale, for NoSQL stores that simply fetch a record by its key, fast and cheap. There's even an irony here. Companies that run heavy analysis on their graphs, like finding communities or ranking influence, often run it in specialized graph analytics tools or libraries, sometimes outside the transactional graph store. So the honest scoreboard: deep chains go to the graph database, sums, reports, and masses of similar records go to the databases you already run. Which brings us back to the original trap. Once a tool has one very clear strength, it is tempting to stretch that strength across the whole project. And that is usually how the proposal grows too large. It arrives through a chain of reasoning. To keep AI grounded in company knowledge, we need a formal model of that knowledge, an ontology. Ontologies are usually written in standard formats like RDF and OWL. Those formats are graph-shaped. Graphs need a graph database. Done. Each step sounds reasonable, and the first steps hold up fine. Structure helps. That is real. And a good ontology can be genuinely valuable. The question is not whether to have structure, it is how to build it. And the real risk is this: making a graph database your default foundation, replacing what you already run without asking what else you do with this data. Because you don't only follow connections, you also run reports and analytics. You insert and retrieve records fast, at volume, you aggregate. And as we just saw, a graph database is not the strongest tool for all of that. So the choice is not graph or no graph. It is keep what already serves those jobs well and add a graph for the parts that are genuinely about connections, where it earns its place, not a rip and replace on the strength of a matching name, even when your knowledge looks like a graph. And as we saw, almost everything does. That doesn't mean it must live in a graph engine, no more than your org chart must live in a dedicated org chart database. And even if you do choose a graph database for some of the storage, there is one more distinction to keep straight. Storage is not the same as reasoning, and this is the part that rarely makes it onto vendor slides. A graph database is very good at storing facts. A is connected to B. Reasoning with business rules is a different job. Take that same food producer with product specifications modeled as a beautiful graph. Products, recipes, ingredients, allergens, suppliers, all connected. Now they want one simple rule. If any ingredient anywhere in the recipe contains this allergen, the finished product must carry this label. The graph holds every connection needed to answer that. But buying a graph database does not automatically give you that reasoning. The rule still has to be modeled somewhere and governed by someone, and in most real projects it runs in a separate layer, a rules or reasoning engine, while the graph database stays what it is, storage. And there's a second cost hiding right next to this one, the language. Your teams speak SQL. Practically every reporting and integration tool speaks it with them. Graph databases speak their own query languages. That means different syntax, a different way of thinking, and far fewer people on the market who are fluent. Every report, every integration, every new hire now needs that extra skill. So add it up, a new technology, scarce specialists, and the business logic still needs its own home. That's what the technology gives you out of the box: storage and traversal, not understanding. Once you see that, the practical question gets much simpler. What already answers the questions your AI needs to ask? And often, the answer is already somewhere in your landscape. Most companies already own tools that do this job. Your business rules engines, the systems that already run pricing, credit, or compliance decisions, are literally rules with reasoning built in. Modern AI can connect to them and simply ask. Your relational databases already hold the facts and the relationships between them, and where you truly need logic on top of facts, there are proven, lightweight logic engines that answer questions directly. Notice the pattern. Usually the AI doesn't care whether the answer came from walking a graph. It needs answers to questions. Whatever answers those questions reliably with the skills your team already has, that's the technology behind your knowledge graph, even if the word graph appears nowhere in its name. So, when this proposal lands on your desk, the decision path is fairly simple. You don't need to learn query languages. You need three questions. 1. Which questions, concretely, should this system answer? Ask the team to write 5 of them down. 2. Do those questions really require chains of unknown depth? Or are they mostly lookups and rules? 3. Do we have or truly want to hire the skills this stack demands? Or can tools we already own get us to value faster? And there's a cheaper first move than any platform decision. Have the team model the entities, the relationships, and those 5 questions in the tools you already own. That's a proof you can run in weeks. If it shows real unknown depth chains, like our genealogy trace, then a graph database enters the conversation with a justification attached. Knowledge graph? Yes, as a concept. Model your knowledge deliberately, and your AI will be better for it. Graph database? Sometimes, when the questions demand it. One smell test to finish. If the strongest argument for a technology is that its name matches the concept, that's not an argument yet.